Hi guys, welcome back to the channel. Today, we're diving into one of the most exciting topics in technology, machine learning. We'll break it down into three main types: supervised learning, unsupervised learning, and reinforcement learning. Then, I'll show you a hands-on demo in orange data mining using linear regression and neural network to make prediction with real data. Let's get started. So first, supervised learning is, think of it like having a teacher. So we give it to the machine, input data, and the correct answers, and we call them labels. So our goal is to learn a mapping from inputs to output. So we label all of the inputs, and then it will give out the outputs. So there are two main tasks here. There are classification and regression. So classification is like predicting categories, like whether an email is spam or not, or regression is more like predicting continuous values, like stock prices. So in our orange demo, we'll use linear regression and neural network as supervised learning models, and we'll train them on label data, test them, and see how they predict new outcomes. Next up is supervised learning, where there's no labels, so the machine only sees the input and tries to figure out the hidden patterns. It's like exploring a city without a map. So there are two common methods in here. We call it clustering, which is grouping similar data points like customer segmentations in marketing, and association, which is like finding relationships between variables like products are often bought together. So unsupervised learning is powerful when we don't have label data but still want to discover the structure in it. So the last one is reinforcement learning. So here the machine learns by interacting with an environment, receiving rewards or punishments, and adjusts its action to maximize long-term reward. So think of like a self-driving car learns how to stay on the road, or a video game AI that improves its gameplay. So this type of learning is widely used in robotics, self-driving cars, and game AI. So now let's switch to orange data mining and see supervised learning in action. So in short, there are two types of data: training data and testing data. So the trained data is learned by the machine, and the test data is to evaluate on the accuracy of our model here. So I have two training data. Here's the training data, and here's the test data on house prices. So next, you want to install orange data mining on your computer, and here's what you get. So you click on new project. First, you always have to input your file in here. So this file is the train data. This is the train file here. House price. Here's the train data. Okay, here I have it. So you can view this data through data table. Here's the data table, the train data. So there are several features in orange data mining that you can take a look at. Data, which is to upload your data. Transform is to select which data that you're evaluating, that you're learning from. Visualize is like those charts and scatter plots to visualize your data. Model is the algorithm in short. Evaluate is to test the model after you have built one. So this is unsupervised model, and the same with associate. So after you have uploaded your file and created a data table, next up is that, so I'm doing linear regression, which is you go to model and drag linear regression. But notice that you have to select which data that you're evaluating. So I do select column to select which data that I'm actually gonna want to predict. So you see target is our house price. So these are the features, these are the factors that contribute to the house price, and our target is the house price. So after that, you connect this to the linear regression. Well, and in here you have successfully built a model based on your input data. So next, you want to test how accurate this model is. So you go to test and score here. So this model will learn from the input data and will be evaluated through test score. So next, we want to drag this select column, which is our data in here. Here you can see we have to learn, we have the data in here, so we'll evaluate. So these are the how accurate the model is. So for MSE, which means mean square error, so this measures how far our prediction are from the actual value. So it squares the errors. So bigger mistakes count more. So in simple term, the lower the MSE, the better the model is performing. So this is the key feature that you have to notice. And R2, which is R squared, this tells us how much of the variation in the data can be explained by the model. So it ranges from 0 to 1. For example, here we got a 0.713, which means our model explains about 71.3% of the variation in the data. So that's a pretty strong result. So next, we have successfully created a model, a linear regression model. Next, I want to do the same for neural network. Here. So simply as that, we connect this to the column with the neural network. And here, we'll see the test score. So for neural network, you see R2 is pretty far, which means that our result is not accurate at all. And also the MSE is very big, which also means that the model is not working well. So next, I want to save these models down, saying that these models have worked successfully and accurately. I should be able to save them and use them for later. Here, save model. Save model. So I saved 2 models down. Here, now click on it, open, and then you want to save this model. So now that you have saved all the models down, you can create another file uploading that model. After you have saved your model, now you want to create a new file. And then you want to open your test file to see if your model is accurate or not. Here I open my test file. See, and now you notice that the test file is shorter than the training data. This is an example. So usually the test data is shorter than the training data. So next we're gonna load in our model that we saved earlier. Okay. So I'll first do linear regression here. So based on these two, we can predict the outcome and see how accurate our prediction was, our model was. So here is my model prediction, and here's the actual price. So the largest error is around 30,000. So you see here, although the MSE is quite big, which means that our model is not that accurate, but the R2 means that it covers 86% of the whole variation of the model. So next, if we want to switch the model into another model that I've saved, which is the neural network, and that will load again. So here you see neural network says 12, and the actual price is 100,066 thousands. So the error is really big, and also the R2 and the MSE is crazy. So this model shows that the prediction is not accurate at all, and it is not reliable. So we need to use other algorithm. So to recap, supervised learning maps input and outputs using label data, and unsupervised learning finds hidden patterns without labels, and reinforcement learning learns from the trial and error with rewards. So with tools like orange data mining, anyone can experiment and see these ideas in action. So if you like this video, don't forget to like, subscribe, and share to your friends who are curious about AI. Thanks for watching, and see you in the next one.